Hello, everybody, and welcome to the notes for Chapter 2, Section 1, which is about reasoning and logic. It is entirely possible that the content in this section will be very new to you, and that is okay. We should be patient with it, and we will learn it together. So a version of these notes without any of my writing on it is posted in the Canvas section with this recording, as are a version of these notes with everything that I'm going to do during the recording. It is up to you which version you want to work with, but it sometimes makes sense to work with the ones, as we've talked about, that don't have anything written yet, so you can do problems as you go. So in this section, we're going to talk about statements, negations, quantifiers, truth tables, compound statements, and kinds of reasoning. To begin with, a statement is a sentence that can be judged to be either true or not true. So when we talk about statements in math, we talk about things that are black and white. They either are or they aren't. And when we talk about statements, they can be false. So we can say something like 2 plus 2 equals 5. It's a statement. It doesn't mean it's true. We can say Pennsylvania is a state in the US. That was true. But what we can't say as a statement are things that are opinions. So Lincoln was a best president. Dogs are wonderful pets. Chocolate is the best flavor of ice cream. Those aren't statements in a mathematical sense. Many statements can be negated. So we can do the opposite of a statement by using the word not. So if we give a statement a name, we could name it P. Generally, when we use statements, we name them P. Oh, sorry, I lost my pen for a second there. Q or R. When we do that, we usually start with the letter P. So if we say, let statement P be a square has 4 sides, its negation, the opposite of it, is that a square does not have 4 sides. When we use a negation, we use this little symbol, not. And what we read is not P. If the original statement is true, its negation is false. If the original statement is false, like that one we saw before, that 2 plus 2 is 5, that's false to begin with. Then its negation, 2 plus 2 is not equal 5, is true. Statements, some statements are really easy to negate. It either is true or it's not true. Other times we have things called quantifiers in our language, and when you speak, if you really pay attention to the words you use, we use quantifiers all day long. We use words like all, some, none, or some are not. So things like all students like ice cream, some people like fish, no one goes to the movies on a Tuesday. Some people are not tall. All of those things are statements with a quantifier in them. And it's a little trickier to negate those. So if we want to negate a statement with a quantifier, if we have the word all, its negation is some are not. So think about it this way. If all fish are blue, I tell you, all you have to prove to me is that some fish are not blue for me to be wrong, right? The opposite side, some, if I tell you some fish are blue, that means at least one, right? The negation of that is for you to prove to me that no fish are blue, none at all. So if I say to you, some people have red hair, you say, no way, I've never seen a redheaded person. No people have red hair. Those are the negations. Okay, and there's a description of them down here. So some A's are B's, or no A is B. Some A's are not B's, or they all are. All are, or some are not, and no one is, or some are. Okay, so think about the fish. So try a couple here. At this point, pause for a second and actually try to negate each of these. Use the chart on the page before as needed. Okay, so let's go through them. The negation of all children like ice cream is some do not. So some kids do not like ice cream. The negation of some students like science is that no students do. The opposite of some is none. No birds are blue. If I tell you there are no bluebirds, none at all, you should say, sure, there are. At least some of them are. If I tell you some fish do not swim, the opposite of that, the negation of it, is that all fish swim. And then down here, Washington was the first president. What's the negation of that? Well, if you read that statement, there is not a quantifier in there. So there's nothing for us to take out. So we can just say Washington was not. Remember that when we make a statement, we make its negation. That doesn't necessarily mean that it's true. It's going to feel weird to write down that Washington was not the first president, but that's okay. That's the idea here. So a truth table is sort of a structure that we can use to determine if things are true or false. Essentially, we use them to go through the possibilities of truth and false. Okay? So they use two statements or more. Usually we label them with letters like P and Q, and some sort of connection. All right? And there's a couple of different kinds that we're going to talk about. These are the operations that we use here. So the first one is a statement and its negation, just like we just did. So if we make a truth table for that, we start out with P. And P can either be true or it can be false, right? Okay. Well, the negation of that is not P. And if P is true, then not P is false. And if P is false, then not P is true. This is what a truth table looks like for a negation. Okay, there's a table here to fill in if you'd like to try it. The next operation we're going to talk about is called a conjunction. It is the word and as we write and we think, okay? It implies that both ideas or events must be true or must happen. So if I say to you, in my kitchen, there's a fish and there's a tiger. Well, if you come into my kitchen and there's only a fish and not a tiger, I lied to you. Or if you come into my kitchen and there's a tiger and no fish, I lied to you. Or if you come into my kitchen and there is neither, I lied to you. So for that statement that I'm making to be true, both of those things have to be in my kitchen, right? There needs to be a fish and there needs to be a tiger. If I say yesterday I slept in and I went out to dinner, two things that never happen in my life in conjunction, I have small kids, then both of those things have to be true for the statement to be true. When we write a conjunction, the symbol that we're going to use for a conjunction is the symbol and, okay? What we do when we read that symbol is it looks like an upside down V. So when we make this truth table, that's the symbol we're going to use to represent a conjunction, to represent an and, okay? So first, let's make our truth table, our statements. The first statement is that we work hard in math class. That's our P. The second, here's our conjunction, here's the and we learn a lot. That's the Q. So let's start from the beginning. Here's the possibilities, right? P can be true or it can be false. But I'm actually going to, think about it like if you flip a coin. There's 4 possible ways, right? Because we have to match them up. P and Q could both be true, right? It could be the case that P is false and true, T is Q, or Q is true, pardon me. It could be the case that P is true and Q is false, that they're opposite of that, or that they're both false. These are the options. Now we have to put them together. So if I want to find out the truth of P and Q, I have to look at the choices I have in my truth table. So think about the fish and the tiger, okay? If I told you I have a fish and a tiger in my kitchen, and I have both of those things, then what I told you is true, okay? We work hard in math class and we learn a lot. If both of those things are true, then this whole statement up here is true. If the first part is false, or I don't have a fish in my kitchen, then this whole thing is false. Because I'm not telling you the truth. If we're not working hard in math class and we think we still learn a lot, the whole thing isn't true. If we work hard in math class and that's true, but we don't learn anything, well, I also didn't completely tell you the truth, so that again is false. And if we do neither thing, we don't work hard and we don't learn a lot, it's like me telling you there's a fish and a tiger and there's neither, that is false. So this is what a truth table for a conjunction looks like for an and. Let's scroll my notes down a little bit. All right, so that's the truth table we just made. A disjunction uses a different connective. It uses the connective or to connect simple statements. When we use or, we're saying that either of those things must be true, but it doesn't have to be both. So I could say to you, oh, there's a fish or a tiger in my kitchen. And you'd be happy if there was a fish, or if there was a tiger, or if there were both, that would be okay, right? But it wouldn't be okay if there was neither a fish or a tiger. So let's make the truth table for that. My car will be ready for pickup today, or my car will be ready tomorrow. So let's set up our P and Q. So the first statement, all the way to the or, is P. My car will be ready for pickup today. Or, the symbol we use for disjunction, for or, is the opposite of and. It's a right side up V. So we're going to use or. My car will be ready tomorrow. We'll call that Q. Okay? And like we did with and, we're going to set up the initial truth table the same way. We're going to go through all the possibilities. Well, they could both be true. P could be false and Q could be true. P could be true and Q could be false. Or they could both be false, right? Then I'm going to figure out what happens if it's an or, P or Q. My car will be ready for pickup today, or it will be ready tomorrow. If both those things are true, then I have a car to drive. I'm good. If my car is not ready today and the first statement is false, but it is ready tomorrow, and that's true, then I have a car to drive. I'm good. If my car is ready for today, but it's not ready tomorrow, well, I have a car to drive today. But if neither of those is true, I don't have a car and I'm out of luck, so that's false. This is the truth table for a disjunction. Okay? You'll notice here that there's 3 ways to be true and 1 false. When we did and further up, there were 3 ways to be false and 1 way to be true. All right, so that's the truth table for disjunction. Now let's try a truth table here. Truth table. It is Tuesday, and I do not have math class. So this is P. And this guy, when it says I do not, is not Q, because there's not in there, right? So if I want to build a truth table for this, before I can do anything else, you think about it like not is a step above the basic, right? P is basic and Q is basic. I always have to start with the ingredients before I make a recipe. P and Q are my ingredients. And then we start adding in things like nots and ands into the mix till we get the whole package. So we start, as we had done before, with P and Q. True or true, true or false, false or true, false or false. But I'm not using Q in this case. I'm actually using not Q. So when it's a not, it's an opposite of what's in the true in the Q column. So that would be false. If Q is false, not Q is true. If Q is true, not true is Q is false. If Q is false, not Q is true. And so now I'm going to do the and, oops, with not Q. So what I'm going to do is pretend that this column isn't here. Okay, so I'm just going to look at P and not Q. So with and, remember, it's Tuesday and I don't have to have math class. Those both have to be true for this to be true. So if it is Tuesday, but I have math class, then this is false. If it's Tuesday and I do not have math class, they're both true. This is true. If it's not Tuesday and I do not have math class, or I do have math class, this is false. And if it's not Tuesday and I do not have math class, it's still not the whole thing true. So there's a truth table with an additional step. What you see here is that we build one step at a time all the way to the right. And as we build truth tables, we build to the right. Oh, scroll down. I lost it. Okay. So now let's make a truth table for not P and not Q. It works very similarly to what we just did, okay? But just like we were just talking about, we start adding columns to the side, okay? Let's see if I have, uh-oh, I just moved slides instead of, sorry, sometimes my slides switch spots on me. So let's make our truth table down here. I want to extend my page a little bit. I'm going to do not P and not Q. That's what I'm writing. But the basic ingredients of a truth table are a P and a Q. So we always start at the same spot. True, 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 false, false, true, false, false. Then I just look at, start building the ingredients. I have not P. Well, that's the opposite of P, right? False, false, true, true. Just looking at P to not P. And then I need not Q, because that's in my recipe. So I'm going to ignore the P's, and I'm going to do the not for Q. I'm the negation. False, true, false, true. Now I have sort of the more complex ingredients. It's like the sauce and the cooked pasta. So I have the not P and not Q. At this point, I'm not looking at P and Q anymore. I'm just looking at not P and not Q. So if it's an and they're both false, well, the whole thing is false. When it's and, if any one of them is false, the whole thing is false. So the only time it's true is when they're both true. Okay? Let's try a truth table that's got something else in it. This one has an R. Okay? So I have a P and a Q and an R. We have to look again at all the possibilities. So I have P, Q, and this is the first time we've seen an R, right? Well, we still have possibilities. True, false, true. Oh, I should have made that first one true so I don't screw up our normal pattern. Where's my eraser? Oh, how about we just erase that and start fresh, because I don't want to make it more confusing than it has to be. So P, Q, R. Well, they could all be true, right? They could be true, false, true. They could be true, true, false. They could be true, false, false. You see where this is going, don't you? They could be true, oops, sorry, false, false, and false. False, true, and true. False, false and true, or false, true, and false. So I have P, Q, and R. And now what do I want to do with them? So I have a P and a not Q. This is in parentheses. What that means when it's in parentheses is we do it first, just like we would in order of operations, okay? So we are going to do what's in this parentheses first. We'll deal with that. So I need a not Q either way, because that's what I'm missing. So let's do not Q. Let's not pay any attention to R or P for a minute. So I got false, true, false, true, true, false, true. Uh-oh, I ran out of screen. False. Now what else do I need? I need in parentheses P and not Q. So in this case, I'm only going to look at P and Q. When it's and, it's only true if they're both true. So false, true, false, true, false, false. Oh, sorry, that F didn't come all the way through. This guy is false. And the last guy is false. And then the last step is to do this P and not Q, which I figured out, or R. So now I'm only going to look at this P and not Q column, and then R. So in OR, it's true if either of them are true. So it's true and false, true. All you need is one, true and true, true, false and false, that's a false. False and true, true, false and false, gets me a false, false and true, true, false and true, true, false and false, false. Okay? So when we get through, we have 8 possibilities here. Okay, if you need to go through that again, you should. And make sure you can go alongside it and follow how it was done. Okay? The next kind of statement we're going to talk about is called the conditional. This is a really common language one. It's if then. So we say, well, if you do this, then I'll do that. It's sort of the bartering, right? But the truth of this is the only time it's really false is when you break a promise. So if you think of this as broken promises, it really helps. So if you get an A in class, I will buy you a car. So if you get an A in class, that's P, then I will buy you a car, that's Q. The symbol for a conditional is an arrow this way. So I'm going to start my truth table with P and Q. True, 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 false, false, true, false, false. And the conditional is if, then. That's how it looks. Now, if you get an A in class and I bought you a car, did I keep my promise? Absolutely. Okay? If you got an A in class and I didn't buy you a car, did I keep my promise? No, I was not nice. If you got an A in class, you did not, get an A in class, that was false, and I still bought you a car. Oh, well then I kept up my end of the deal. That's true. If you didn't get an A in class, the bottom one, but then I didn't buy you a car, well, did anybody have to keep a promise there? No. So that's also true because nothing was broken. You didn't do your job, I didn't do mine, everybody was happy. This is the truth table for conditional. Okay? All right. This is a very similar one. I find this one kind of confusing. Sometimes you should try it, but we don't all feel the same way about French fries, it seems, which is why this one can get a little confusing. You are going to get plenty of practice with this in my math lab, so don't stress over one example. A conditional statement, in the conditional statement, the first part is called the antecedent. It's a hypothesis. And the second part after the then is called the consequent or the conclusion. Okay? Sometimes when we talk, there are hidden conditionals. Sometimes we don't even hear them, but we're using them and we don't realize it. So if I say, Tom always buys a Buick, well, what I'm really saying is that if Tom buys a car, then he buys a Buick. If I say something like, Sue always buys a toy when she's in Disney World. Well, what I'm also saying is that if she goes to Disney World, she'll buy a toy then, okay? So there is a secret connective in these like always kinds of statements that is a conditional statement, okay? All right, so let's do a truth table for P, if then, not Q, okay, the conditional. So where do we start? Well, we always start with P and Q, right? Same as we've been doing. True, 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 false, false, true, false, false. You could try it. So pause and try it yourself or follow along. Now look at the ingredients. We have the basics. Let's go up a step. What do we need next? Well, we need not Q, right? So there's not Q. Let's negate Q. Here it is. Here's my negation. And then let's do P, then not Q. So we're going to ignore Q here because we're only using P and not Q. Remember, it's about broken promises. So if you got an A and I didn't buy you a car, that's false. I broke my promise. If you got an A and you got the car, true. If you didn't do either and neither of us did a problem, I didn't buy you a car, you didn't get the A, true. You didn't get the A, I still bought you a car, it's true. So there's the truth table. Okay. The next kind of statement is called a biconditional. It connects two simple statements. What it means is that both have to be true or false for the statement to be true. Otherwise, it's false. A biconditional means they both have to be the same truth value, okay? For example, I will make you dinner if and only if you buy me a present. The symbol for biconditional is a double arrow, okay? So we'll start the same way. Here's my P, I will make you dinner. Or you will buy me a present. If and only if is the biconditional in between. A lot of times you'll see it written as IFF, if and only if. So we start the same way we've been starting with the possibilities, right? True, 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 false, false, true, false, false. And then let's think about the biconditional. P, if and only if, Q. So if I make you dinner and you buy me a present, this is awesome. It's perfect. It's true. If I make you dinner and you don't buy me a present, there's trouble. That's false. If you buy me a present, it's true. And I don't make you dinner, we also have trouble, right? But if I don't make you dinner and you don't buy me a present, then we're good. That's true. Okay? So this is how a biconditional works. You can make your table here if you like. All right. Remember that you don't always have to make an entire truth table to determine the truth of a statement. You can do sort of one piece at a time as you need to. Sometimes you get enough to start with. So for example, if I know P is true, Q is false, and R is true, then I can figure out some things. So I'm going to make some labels in here. I know P is true, so not P has got to be false, right? I know Q is false, so that's going to go right here. I know R is true. Okay, so I'm going to fill those in. Now, look at the first piece here. False if and only if true. Well, we just learned a second ago that the only time a biconditional is true is if they're the same truth value. These are not the same, so that's got to be false. Then let's look at this parenthesis. Not P is false and R is true. Well, the only way for an and to be true is if they're both true. So that's false. But then look what we have last. We have a false if and, a false if then a false. Well, that's you didn't get an A and I didn't buy you a car. That's true. So the whole thing is true. That's how it works out. Okay, there are some special cases in truth tables. I'm going to pause here and I'm going to start a new video so that you guys have a minute to digest and come back to this.